All right, we are going to discuss overloading versus multiple dispatch. And the reason I'm talking about this is because I used to be so confused about the difference between the two. Um, and so I actually think it's not too bad. So that's what I'm going to hope to explain. Okay, so first of all, we're talking about function overloading and multiple dispatch. Okay, what are the differences? What are the similarities? Um, so first of all, and we'll talk about the similarities. So first of all, they're both writing different implementations for the same function name, but on different types. So for example, if you have some function called foo, and you want the implementation to be different on an integer versus a string, both overloading and multiple dispatch will allow you to do that. Okay, so that's the big thing. And then this next part, it might sound obvious unless you've been in a situation which it doesn't apply, but it allows you to choose which implementation based on all of the arguments instead of just one or maybe two. So for example, like if you were writing some function called like add, like addition, you could overload or do multiple dispatch based on both of the arguments in the addition, right? So you could have one implementation for a float and an integer, another implementation for an integer and a float, and it would be able to dispatch based on all of the arguments. And again, that might seem like obvious, but it really isn't, because there's some situations in which some functions in some languages only dispatch based on one of the arguments. So both overloading and multiple dispatch on all of them. Okay. And so given that those two things are the same, what's the difference between them? And the only difference between them is that overloading determines which implementation to choose based on the compile time type, the static type, right? Whereas multiple dispatch chooses which function to use based on the runtime type, or some people call it the actual type or the dynamic type. Okay, so that right there is the whole difference. Overloading chooses which implementation to use based on its arguments at compile time, and multiple dispatch chooses which implementation to use based on its arguments at runtime. Okay, and now this is the part that always confused me. Is I was always like, well, I don't understand why the compile time type would be different from the runtime type. Like it seems like those two should be the same. So like why are they different? And again, that was my biggest hang up. And it turns out the answer is actually simpler than I thought it might be. And the answer is that the runtime type versus the compile time type, they're not different. It's just that the runtime type can be more specific in some circumstances. So I'll give you some examples. Or I'll give you a counterexample. So one thing that doesn't happen is, let's say the compile time type is like a string, and then the runtime type is an integer. That wouldn't happen because those are totally different. So again, it's not that the runtime and the compile time types are totally different. It's just that the compile time type can sometimes be less specific, and the runtime type can be more specific. And so an example of when it happens would be if at compile time you have a union type. So for example, maybe you're reading something from the console, and maybe your read console function, its return type could be a string or it could be an integer. Right, so usually that would be like a union type of a string and an integer, sort of like an either or. So at compile time, you have a union type, a string or an integer. And so your function overloading would choose the implementation based on the union type. Okay, but then at runtime, once you call that function and the user types something in, let's say they type in the number 4, and so the function, read from console has returned an integer. Now, the dynamic type of that variable is going to be integer, whereas the compile time was union of integer and string, right? So if you can dispatch based on the runtime type rather than the static type, then it will choose the function implemented for integer rather than union of string or integer. Do you see that? So again, it's not different. It's just like sometimes the runtime has a little bit more information because it knows what is actually happening, right? It can be a little bit more specific. So in that case, the dynamic situation, the multiple dispatch situation, can choose the implementation based on just the integer rather than the union, okay? So that's one example. One other example, and this one, I don't know if it's more common, but this might be the example that's given, is in like inheritance trees and subtyping. So with like dynamic dispatch and like the runtime type being different from the compile time type, a lot of times with inheritance, let's say you have like a car superclass and then the subclass is a Civic, a Honda Civic, right? So the Civic is more specific, so it's a subclass. So a lot of times the compile time type will be a car, the more general case, the superclass, right? And then the runtime type will know exactly which type of car it is, whether it's just a car, like a general car, or if it's actually the specific Civic, right? And so if you allow for dispatching based on the runtime type or the actual type, then in that case, it will know to dispatch the function implemented on the Civic rather than the function implemented on the car. So that's the biggest difference. And again, you can think of that as a situation in which at runtime you just have a little bit more information. Like you just know a little bit better where the actual value is. And one thing you can actually do, so our first example was the union type. And the second example was the inheritance tree. And if you think of the inheritance as like a union type, as like, okay, so a car type is sort of the union of a car and a Civic, then you can think of really the whole problem just boils down to union types if you want. If you think of the inheritance and the super typing and subtyping as an example of unions. So yeah, I think that's the whole thing. That's just the difference between function overloading and multiple dispatch, and we'll kind of go into some more stuff later. Thank you. Bye.